Hello, everyone. Welcome. Thank you so much for being here and for your time and attention. My name is Tamra, and I'm here to talk to you today about something called biomimicry. Now I can see the confusion on some of your faces. Bio what? What is that? Don't worry, you'll hear all about it in a minute. And if I do my job well, you'll not only know what it is, but why it's useful. In order to get this idea across, I'm going to be sharing with you some examples, but I hope it doesn't feel like a lecture because I don't want any of you struggling to stay awake like I used to do in class. I mean, right? Let's be honest. I wasn't much of a fan for school. Greatly disliked it, in fact. But I enjoy learning. I love knowledge. I like to learn about things that I want to learn about, not things that I have to learn about, as I'm sure many of you can relate to that. When I was growing up in Florida, a knock-kneed, scruffy little girl running around our neighborhood, I used to like to try to catch things and poke at things with sticks, anything that creeped or crawled, terrorizing them and myself in the process. But I enjoyed engaging my curiosity in these ways because it was what I wanted to do. And under my own autonomy, teaching myself about the natural world. You throw that into the mix with how uncomfortable it is to sit in a classroom all day around a whole bunch of students that don't even want to be there. And then you have a recipe for someone who enjoys learning but dislikes school. So fast forward many years into the future, when I'm mired in the responsibilities of being an adult, doing a whole bunch of things that I had to do, when I came across this article that stimulated my curiosity. It was a story about a local company in Gainesville, Florida, that was awarded grant money to create a urinary catheter with a surface that mimicked shark skin. Because when you put shark skin under a microscope, it has a repeating pattern that keeps the bacteria from being able to stick to it, so that when the shark moves through the water, it's like a self-cleaning mechanism. And I was just beginning my studies as a nurse when I came across this article, so I was learning about how big of an issue urinary tract infections are from catheters in the healthcare industry. But this set off an explosion inside of me, this fascinating concept, this biomimicry. And for the first time in a long time, I got excited about learning things again. This idea that you could go to nature and study how the wild world solves for problems that are similar to what we face as humans. Bacteria sticking to surfaces is one of them. And it got me thinking. I was like, well, what else do we use this biomimicry for? So I started to search for the concept when I wasn't doing things I had to do. And that path eventually led me straight back into more school, into the Master of Science in Biomimicry program at Arizona State University. And in that course of study, I learned that biomimicry is the conscious emulation of nature's genius. So organisms in the natural world have been adapting to a barrage of challenges over eons, learning how to use less and less energy in order to get their needs met. And this leads to some really interesting, thought-provoking design ideas. For example, here in the United States, we love our stuff. We like to go and buy stuff and bring it home and use it once or twice and then try to get rid of it. So you can take this same sort of idea, the same challenge to nature and ask, well, how does the natural world handle stuff? Now, there's an idea that I want you to keep in mind, and that's from a design perspective, there are different levels to a challenge. So in the case of stuff, at the level of form, am I trying to create a new trash can or a new trash bag? The next level up is a process. Am I trying to figure out how to collect a whole bunch of stuff and throw it out? Or is it a system? Am I at a citywide or a nationwide level trying to figure out how to handle flows of trash. If it's a form that I'm after, what do we do with waste now? We throw it away into a trash can, right? We contain it. So a biomimic would ask, well, how does nature contain stuff? You can see this little guy. This is the poplar spiral gall aphid. And that thing in the center, the spirally thing, that's the spiral gall. And that's a structure that the aphids, shall we say, encourage the poplar tree to construct so that a social environment, they can all live inside this little spiral gall. Well, the aphids, they deal with a whole bunch of sticky solutions that they can't afford to have their bodies covered in because these aphids are flying insects. So if their wings are sticky, then they can't fly around taking care of all their little aphid business. So they have these specialized cells on their abdomens that create this powdery wax discharge that when it comes in contact with the solution, the sticky solution, it surrounds it and covers it and coats it, creates this little wax marble that's very easy for the aphid to manipulate and roll around and dispose of. Wouldn't that be cool for our own issue with trash? We can just roll our trash into a wax ball and roll it down the driveway instead of having to drag it or carry it. So the next level of the challenge is the process, right? So the process of stuff. We could say as a biomimic, how does nature handle waste? But nature doesn't really create waste. Everything is used and used again in the natural world. So we could say, how does nature handle excess? Because there are times when there is too much of something, like in the instance when there's too much water that falls from the sky onto these plants. This example is a biomimicry solution that's in use today. It's a low-cost toilet that mimics the process of evapotranspiration in plants. So when there's an excess of water that's being drawn up through the roots into the body of the plant pushes this excess of water out the top into these tiny little holes called stomata that are all over the surface of the leaves. So when the water gets to these stomata, it turns into a bead that if it sits there for a little while and eventually turns back into a gas and re-enters the water cycle. Don't worry, I'm not going to take you back to that lesson about the water cycle in biology. Just trust me when I say that it's a good thing when water turns back into a gas and returns to the air. So this toilet mimics this process in an area where water for flushing things down toilets is really at a premium. And in fact, the network of pipes that exists to carry the waste away doesn't exist. So this toilet has a unique type of bag inside of it so that when this mixture of fluid and solid that the human body deposits in there, eventually this water that's in there is allowed to leave the bag again, but only when it returns to a gaseous form. So then all that's left is this small, tiny little amount of compostable material that's then very easy to dispose of. And remember, from the perspective of a forest, nothing is considered waste. Branches and leaves, scat that animals drop, seeds, flowers that die and fall. Everything drops to the ground, and the microbes in the soil decompose all of these things and return these nutrients back to the plants, which then return them to the animals that eat the plants and the fruit. And this is an example of a system that humans can mimic. A circular system. A group called the Ellen MacArthur Foundation is taking this idea and applying it or mimicking it in our cities, where they're stepping into these flows, these linear systems or linear economies where we extract a finite resource and create a whole bunch of single-use items, and we use them once or twice and then we throw them away. That's a linear economy. Well, nature is teaching us how we can cut into that flow and reorient it so that it's actually a circular economy where these things that we produce at the end of their lives, they can be reabsorbed into the system, broken down, and then reconstructed as something new that we need. So you can see how useful a tool that biomimicry is. anytime that I've ever tried to explain what biomimicry is to someone, I've never really had to sell it. It sells itself. This idea that you can go to the natural world, into a library of living examples that have been adapting to challenges far longer than any humans have. And if you're not convinced, then I encourage you, no, I challenge you, the next problem that you encounter in your life, ask yourself, how would nature handle this? And it doesn't have to be a tangible thing like, how do I deal with this piece of trash? It can be an abstract thing like, how do I deal with this massive issue of all of these single-use items that's building up in a landfill? And I bet that you'll find that it's a really beneficial way to approach your problems. It might even turn into something that stimulates your curiosity. It might turn into something that you find that you don't have to learn, but something that you want to learn. Thank you very much.